Friends, my discussions is ring theory. Okay, in my previous class, whatever you have learned, definition of the ring theory, definition of the ring theory, and unit of the ring theory. Okay, and with examples. Friends, whatever we have learned, I recall again. When it is ring theory means it is r plus dot is called r plus comma dot is called ring. When friends when a plus, in case of plus it is abelian. When r plus is abelian group, when r plus is abelian group abelian, and r dot is semi subgroup means semi group. When r dot is semi group and r plus is abelian group and distributive property will hold, then it is ring. Then r plus dot is called ring. Now I will discuss zero divisors, because this is very, very important, because if you understand zero divisors, then you can understand ideal. Okay, you can understand integral domain. Okay, zero divisors, if you understand, then you can understand integral domain, because integral domain is related with zero divisors. So what is the zero divisors? Zero divisors is an element a does not equals to 0 is called zero divisors left if b does not equals to 0 and a dot b equals to 0, and right zero divisors if there exists c does not equals to 0 such that c dot a equals to 0. Such that c dot a equals to 0, then it is right zero divisors, friends. And now again I will discuss whatever I have to discuss. I have to discuss some example. I am choosing some example. Example: find all zero divisors of z plus comma dot. So friends, z means z equals to, you can write plus minus 1 and 0 also include plus minus 2 etc. So in here you will see 1 dot b. In case of 1 dot b equals to 0, not possible, does not equals to 0. Any number, if you will multiply with 1 and any numbers, then you cannot get any number that it is 0. So z does not have any 0. Z does not have any zero divisors. So friends, it is as it is not zero divisors, so z is called integral. Z is called integral domain. Z is called integral domain. So if you understand zero divisors, so you can understand also integral domain. Integral domain, what is the definition of the integral domain? Integral domain, this is very, very important to know. Integral domain means let r plus dot is said to be integral domain if and only if there is no zero divisors. There is no zero divisors. R comma plus comma dot is zero ring, no zero divisors, zero divisors. Integral, this is called integral domain. It is a ring, okay, r plus comma dot ring, this is called integral domain. So friends, no zero divisors means integral domain, and when you can get zero divisors, it is not integral domain. So it is very, very important to know definitions of the zero divisors. This means, whatever this means, that a dot b does not equals to 0, both a comma b does not equals to 0. So you cannot get any number which is not 0, and a dot b, it does not equals to 0. This is called integral domain definitions. Integral domain is very, very important for ring theory. And next I will discuss, I want to discuss Z4. I want to discuss Z4. So friends, the element of the Z4 is equal to 0, 1, 2 and 3. 0, 1, 2 and 3 Z4. And for 1, whatever you get, for 1 you will not get any 1 with any multiplications. You cannot get any multiplications with except 0, okay. And dot a does not equals to 0 when a does not equals to 0. So you cannot get any number. So 1 is not zero divisors. 1 is not zero divisors. So friends, so again I will get 2. So 2 dot 2 is equal to 4, and 4 bar is equal to 0. So, and where 2 does not equals to 0, that means whatever we get that it is zero divisors. So I get also a element zero divisors. So Z4 is not integral. Z4 is not integral domain. Z4 is not integral domain. Must remember. So Z4 is not also field, because integral domain field is subset of integral domain. Integral domain field is proper subset of integral domain. Means field is here, it is field, and it is integral domain. This is integral domain. Integral domain is a field contains in integral domain. So it is not field. When zero divisors, when it is present in the ring, then it is not integral domain and it is not a field. So I discuss, and so Z4 I get a zero divisors, so it is not also integral domain and it is not also field. But it is, Z4 is also a ring. How can I prove? I can prove it easily in case of plus. Z4 is a ring, and 0, I write 0, 1, 1, 2, 3, and whatever I get, 0 plus 0 is equal to 0 plus 0 is equal to 0, 0 plus 1 is equal to 1, 0 plus 2 is equal to 2, 0 plus 3 is equal to 3, and 1 plus 0 is equal to 1, 1 plus 1 is equal to 2, 2 plus 3 is equal to 3, and 0. 2 plus 0 is equal to 0, 2 plus 1 is equal to 3, 2 plus 4 is equal to 0, and 3 plus 2 is equal to 1. And 3 plus 0 is equal to 3, 3 plus 1 is equal to 0, 0, 3 plus 2 is equal to 1, and 3 plus 3 is equal to 6, means 2. So friends, whatever I get that Z4, plus is abelian group. This group is abelian group and Z4 4 comma dot 4, it is semi group. What is the meaning of the semi group? Semi group, I have told that it is hold associative property. It holds associative properties. Then it is called semi groups. Semi groups and also distributive property also hold. Let's see that semi groups how it is the 0 0 1 2 3 4 0 1 1 2 3. If we will get graph and 4, then 0 means 0 into 1 0, 0 into 0, and 0 into 2 0, 0 into 3 0, 0 into 4 0, 0 into 0, and 1 into 1, 2 into 2 into 3 into 4, and 2 into 0 means 0, 2 into 1 is equal to 0, 2 into 2 is equal to 0, and 2 into 3 into 2 into means 2, and 4 into 2 8 divided by, sorry, this is not 4 is not include, so whatever I get 0 in case of 2 this is, and 3 comma 0 means 0, and 3 into 3 2 ja 2 and 1. So according to this, whatever I get that a dot b equals to 0, a does not equals to 0, and b does not equals to 0. So whatever I get that so friends, next discussions is nilpotent element. Definitions is nilpotent element. Let R comma plus comma dot be a ring and element A belongs to R is called nilpotent. Briefly I discussed. Okay, you can get a lot of books where also they give definition. This definition is very simple. That is called nilpotent if a to the power n equals to 0. A to the power n means a dot up to a. This is the n time multiplications and it is 0. So this means a to the power n. This element is called nilpotent element. And next definition is idempotent element. Definition is idempotent element. Also you have learned that whatever you have learned idempotent matrix, you have learned idempotent nilpotent matrix, but here in case of ring there is definitely idempotent element and nilpotent element. In case of ring you get element, one is idempotent, another is nilpotent element. An element meant A belongs to R is said to be an idempotent if same set is square is equal to A. In case of matrix, we have learned that A is a matrix and A square is equal to capital A. This matrix is called idempotent matrix. Idempotent matrix you have learned. And similarly, same things, nilpotent matrix, when a to the power n equals to capital A is a matrix and a to the power n by a to the power k is equal to 0, then this matrix is called also nilpotent matrix. Similarly, nilpotent element also same, a to the power n equals to 0 and a square is equal to a, means capital A square. This is idempotent element. Example is simple. Example, in case of nilpotent matrix, if you take Z4 where you can get 0, 1, 2, 3, then whatever you get 2 plus 2.2 is equal to 4, means, and 4 bar means is equal to 0, so 2 square is equal to 0, 0, 2 means in here this is 2 is also nilpotent element. And another fact that you will, this is the concept. Another concept is or other note, you can say that in any ring 0 and 1 are called trivial idempotent elements. In any ring 0 and 1 are called trivial idempotent elements. Example is Z is trivial idempotent element, 0 and plus minus 1 and plus minus 2 and plus minus 3, etc. And you will say that 0 and 0 square is equal to 0 and 1 square is equal to 0. So it is a trivial idempotent matrix. So friends, thank you, and next time I will discuss Gaussian integers and ring field, skew ring, divisors ring, a lot, prime ideal, maximum ideal, everything. So I will discuss. Thank you for watching.